the webinar, to the latest webinar of the MIA specialist group of IWA, which is organized by the Hybrid Modeling Working Group. So you will hear more about the MIA and the working group in a moment. I just want to welcome you all into this webinar and give the floor to Marianne Schneider. She's a postdoctoral researcher at the Ghent University and the chair of the Hybrid Modeling Working Group at the MIA. And yeah, Marianne, the floor is yours. She will introduce you to the Hybrid Modeling Working Group and a bit of this competition.
Thank you, Saba, and hello, everyone. Welcome to today's seminar. So, just quickly for the agenda before I introduce the Hybrid Modeling Working Group. So you will have to well as to MIA. It will be very short, and then Christian will talk about version control in Git. Then I will talk about virtual environments. Then we have a nice example with PyPy, and then it's really hands-on session. But also already earlier you will see that you will have something to do on your computer already. So yeah, please keep your computer ready and join really hands-on. And then we have breakout rooms during the hands-on session in the later part that you really, if you have any issues, you can ask and we can help you to troubleshoot whatever you have. Okay, yeah, just that you notice the session is being recorded. Please don't overly use the chat function, but if you have questions, yeah, don't worry. Yeah, sorry, we didn't actually do the question answer session. I should have removed that. And the microphones and camera are disabled. However, if you have a question, just basically. Okay. So who is the Hybrid Modeling Working Group and what did we do? I think we are a rather recent group, which is quite active. So we all met in 2021. Then we published the first article before even founding the working group on hybrid modeling. And in September 2020, we got accepted as a working group by MIA, so the Modeling and Integrated Assessment that is also organizing this webinar. And then we did a workshop on hybrid model, how to build hybrid models for water reuse facilities. Another workshop on surrogate modeling. And now we have this webinar on good modeling practice. And then we actually have a Kaggle competition that we also would like to quickly talk about because that might be very interesting for you, especially. So the submission deadline is in about a month. So you have exactly time to participate if you want. And yeah, to show you all the faces of the Hybrid Modeling Working Group that we are currently. And yeah, feel free to contact us anytime. I'm currently the chair and Junji is the vice chair. Sina was the chair before. But yeah, anybody here can be contacted. So yeah, what is the competition? So in other fields, Kaggle competition is actually something that is very frequently done. In our field, I think a bit less. And we thought, okay, that might be a really nice way to get good coding and good modeling practice into our fields, and actually basically also to really use it as a basis of discussion for good modeling practice for hybrid modeling as such. And that's why we launched this competition where you get data and a mechanistic model. The mechanistic model is in Python, open source. It's actually introduced later on in this webinar. PyPy it's called. And then you can do a prediction for a wastewater treatment plant that we provide with data-driven mechanistic or hybrid modeling. And join the competition, and we actually have a quite nice prize. So it's like 500 euros for either for both like the highest score as well as also the best modeling practice, which is jury awarded. And sorry, the deadline we postponed to the 8th because then you have 1 month from now, basically. Yeah, I think I said already before, so I will not repeat myself, but I will hand over to Saba for the MIA introduction. Thank you.
Okay, thank you, Marianne. I will share my screen. Do you see my screen, Marianne? Can you confirm?
Yes, I see.
Okay. Yes, I will give a very brief introduction to the MIA specialist group. My name is Saba Daneshkar, and I'm also from Ghent University Biomath Group. And together with Elena Torfs, Elena Torfs is the chair of the Modeling and Integrated Assessment Specialist Group, and I'm with the vice chair. And we are happy to be here to co-organize with the people of the Hybrid Modeling Group this webinar today for you. MIA is actually one of the many specialist groups. In total, I think there are 50 specialist groups at IWA. We are one of the most active ones, and the idea of the whole MIA specialist group is to promote the use of models, computing tools for supporting the understanding, management, and optimization of water systems. We are also targeting a very broad audience, not only people from academia, but from any research institutes, consulting companies, utilities, operators, and anybody who is active actually in the whole modeling community of the water systems. And we also interact with other specialist groups like the ICA, for example, and also promote the collaborations and activities within the academic and professional organizations. You can see on the right-hand side some links to the places on the web that you can find more information, but I will talk about this in the last slide again. So we do a lot of actually different activities within the MIA, and one of the most important ones, and also quite related to the hybrid modeling group that we talked about a little bit, and Marianne mentioned about that today, is the organization of task groups and working groups, which are usually a group of people gathering to perform the case of task group, a certain task for a limited amount of time. And you can see examples of that, like the good modeling practice is one of the famous one that you have most of you have already heard about that, or the implementation of the BSM or the benchmark simulation models, and also working groups, which have a bit broader concept, let's say, so more people can be involved, and there's also no time, let's say, limited time duration for that, but they are actively working on the topic. For example, in the case of hybrid modeling, in the case of this group that is organizing this webinar. And both task groups and working groups, they are usually report their activities at the end of their time that they do, for example, the tasks or a specific task in something that is called the scientific and technical report. And you can see the example of some of them that are recently published, and most of them are openly available on the web, like for the greenhouse gas emission, PCM, physiochemical models, and CFD. These are the very recent ones that are available. We also do organize conferences and events, and very active in that regard. And WRRF and WaterMatrix conferences, these series are the two main conferences that MIA is actively supporting, or the organization of that. The latest one was actually the last WaterMatrix, which was held in Quebec in September 2023. And the next one is the upcoming WRRF, which will be in the US, in the Notre Dame University in Indiana. And after that, there will be the next WRRF 2026, which will be officially announced, the location of that, or maybe it has already announced on some places. You might have seen that. Yeah, so that's it. And I don't want to take a lot of time here. If you do want to get more information about the other activities that we do as MIA specialist group, please make sure to follow us on different platforms. So we are actively involved in the on many of the social media that you can see here. Like we have an active LinkedIn page, the IW Connect Plus, the new platform of IWA. We are also active there. We have also a Twitter account, and we do announce a lot about and quite often about all the activities that we do and organize for the modeling community. And the last point is that if you're also interested in joining the MIA management committee, so in the management committee, we have a group of senior members and young water professional members who are collaborating with each other in groups of, in pairs of young water professional and senior members. And we will have new positions available for the new young water professionals that they can join the management committee and then get involved in the activities that we do. And so please check the IWA Connect Plus and LinkedIn, as I said. So the announcement will be there very soon. And if you're interested, then you can fill your application and you can hopefully join us in the MIA activities. That's it. So this is the agenda for today that you have already seen. And the first part, we move to the version control with Git. And for that, we have Christian Gomez Cortes from Biomath, Kent University. He's a PhD student in our group. And okay, so I will stop sharing so he can share the screen.
Yes.
Okay. The floor is yours, Christian.
Thank you very much, Saba, and welcome everybody. Can you hear me and see my screen properly? Yes. Okay.
Yes.
That's wonderful. Well, welcome to version control with Git. I hope that you can learn a lot with, even if you don't know Git, or if you know a little bit, you can learn new good practices to implementing with control version. So we will start with definitely what is version control and Git, and how to get and use it. And we will end up with some basic commands on how to implement this Git application. So let's start. First, I want to thank everybody that helped to contribute to support these slides and get information for the presentation that you are going to see today. So yeah, first, what is version control and why should you use it? So let's imagine that you have a water resource recovery facility, and you create a model from that with all the best modeling tools that you know, and the programming languages that you want. You compile everything, slides, the documentation, everything in your model, you compile it there, and you create some outputs. Pretty simple, pretty straightforward. And now let's say that you, from your model, from all those files that you have, you want to make some changes. Your boss, promoter, supervisor said, we need to test new cases. So you create a model version 1. You keep your model and you want to create a model version 1. But that's not enough. You create another version and then you produce results. Well, here you start seeing what maybe I'm talking about with version control, is that when you want to make some changes in your model, you normally create a copy and you make the changes in those files that you want, and you start branching, start creating more files, and you end up with a lot of files and probably a mess around it because you don't know where to get information and where to start. So that's actually what version control helps you with, to organize these branches, organize the information in each of the files, and allow you at the end of the cycle to keep your model where you start from, that is normally called main or master branch, and allow you as well to work in a side branch for fixing issues, testing new cases, adding more components, units, for example, if it's a water resource recovery facility model, or testing just new information that you want in a different model that requires some modifications. After that, something as well that allow version control is not just let those branches aside, but as well to merge it in a new model. So you gather everything that works in your model, in your first model, and implement in the previous one, everything that you feel that works, everything that will be useful for you, and you create a new model that will be then your starting model to continue your work. Let's say after you fix an issue or implement new cases, as you can see here. But this is not everything that you can do with version control, but as well restoring previous version. Let's say that if you encounter an issue and you need to turn back to a previous model, to a previous version, you can do it in everything, because this version control system will store those changes and all those versions along time. So you can actually restore your information, keep a track, and as well compare how different files are evolving and what are the changes that you're implementing with. So what is Git? Why maybe you heard of, and that's the reason why you are probably here. Well, Git is an open source and free source control management, or SCM. It basically means everything that I just said. That is, Git is the software that allows version control. It's not the only one, but is the most common one, let's say, and will help you with everything that you need to implement this version controlling and track your files along you evolve in your project. Where first, where to get Git? You can get Git from this site, that is Git -scm, and you can download it from Windows or Mac, depending on Linux and depending on what you're working on. And normally Git will, once that you download it, if you didn't do it yet, please do it, because you will need it afterwards. It will came with a Git bash, that is a terminal. And Git will run not just in the terminal that you can download with Git, that is Git bash, but in any terminal that you are working on. If you're working in Windows, probably PowerShell or CMD. If you're working in Mac, your terminal will work as well with Git. And you can simply code everything that you need from the terminal. So an important disclaimer that I think that this is something that people commonly confuse on. That is what is different between Git and GitHub. Okay, Git is basically the version control system, is what I described. It will track your files, it will organize how they evolve along time, track difference. And GitHub is basically the online platform of the website that allow you to submit those files structure, and share it with others. It allow collaboration and as well backup in the cloud. But it's important to say that GitHub is not the only one that do this, but it's the most common one and probably the one that creates confusion between Git and GitHub. Well, now I'm going to continue on basic commands on Git. So if you have your terminals ready, please open them. And probably you will ask me, okay, I have my terminal ready, and you will see a black screen with some code there, but you don't know where to start. So the first thing that you're going to start on is your working repository. So where are actually you're going to store all your information? Let's say that you're going to store it in a file that is called new model. Then you will change your directory from your current directory to the location where you're going to work. There are two ways to do this. The complex one, you can call it, is type in your terminal change directory, cd, and the path that you are going to follow, c colon / whatever that you are going to follow. Or if you want to make it simpler, you can go to your file explorer, go to the folder that you want to work on, and then in this part you are going to type cmd, and that will open the terminal in the current directory file that you're working on. To continue, when you already are in your directory and you want to start Git, the first command that you are going to type is git init. This command will create the Git file that if you click on hidden elements, probably you will see it as a folder, but normally you will not be able to see it. And that contains all the structure that you requires to track your different files that you're working on that directory. If you want to see what are the status of your files, what are the files that contains that directory, and if they are currently going to be tracked or not, you can type git status, and that will allow you to see, for example, here as an example, untracked files, demo file. Demo file in red means that it's not being tracked, and you will need to track it, and I'm going to explain how. Before going any further, I would like to let you know that it's as well a help command. If you have any questions or doesn't understand what's going on with a specific command, you can type git help and the command that you want to know more about, and that will display locally in your machine everything about regarding the command. So if you type, for example, git help init, it will open your browser with everything, all the documentation, what is it, how you can add more, or what it requires to work. And you can do it locally without internet if you need it. So now let's say you have all your files, you start the git command and you want to add a file. You want to add a file to start tracking that file, all the changes that you are going to do to that file. So there are some ways that you can do it. The first one is git add and the file name. I'm going to use the pointer here. You can use git add and the file specifically that you want to add and to start tracking. There are as well shortcuts. If you want to add all the files, you can type or a dot. That is a shortcut to add all the files that you have in your folder, or you can type as well all, and that will allow you to follow. And you will see something like this. When you insert git status, that will say your file 1 and file 2 is not currently tracked. But if you add a git add and dot, that will add all the files that you have in your current folder to start tracking the changes that you are going to make, and then now you can see them in green. We will have an example afterwards, but if you want to start trying, please feel free to do it. Then something that probably you heard from your colleagues or for people around it is that once you start tracking your files is not enough. You need to commit them. But what exactly is commit? How do you do a commit, and what is it? Well, a commit is basically save a copy or a milestone of the current status that you have of your files. Let's say that you take a snapshot of the current status of your files and you store it in a book. So if you have a book to start tracking what you are going to do, you save that information in a page and you can continue working on a different status. So let's say we set to the Git system, we want to start tracking our files, and we want to commit them. We want to store them in that file. So how can we do it? Well, you can do it with this command that is git commit, and you can add a message to it. Typically, it could be whatever that you want, but a suggestion from us is that you keep your messages meaningful, because this will help you afterwards to really know what you change, and will be easier for you to know how to approach to this if you have encountered an issue or something similar. So we present to you this format that allows you how to properly document your commits, what you change in this specific time. And for example, here we said we change file number 1 where we implement a new function that will print, and we resolve issue number 69. The idea is that you implement what kind of command it is, if you improve or change a file, a specific file, a brief description of what you did, mention if you resolve an issue or if you are working on an issue, in order to afterwards it will be easier to go back and see what are you actually working on. If you would like to see what are the difference between the previous and the new file that you have, you can use git diff, but I'm not going to do any further on this just to save time. But if you want, you can try it. That will split the difference between the files. Just to wrap up of what I said, basically you have different areas in Git. The first one is the working directory, that is where you are working currently on. Then is the staging area, that basically that will tell you what are the files or the modifications that you want to track. And then is the repository of the Git directory that allow you to store all the current information that you have or have been modifying. And then you can recover it afterwards if you need it, if you need to restore or to track the different modifications that you have been done along the project. To continue how on how to add files to the staging area, you basically will just use the command git add, and that will allow you to add the file that you want. But if for any reason you want to go back, you can use this command, restore stag it, that will move back your file to the working directory. And finally, just remember that anything that is committed in Git can almost always be recovered. However, anything you lose that was never committed is likely never to be seen again. And with this, I allow Marianne, please, to follow the next part of this, and I hope that you find this interesting. Thank you.
Thank you, Christian. Okay, so we will go back to Marianne to talk us a little bit about the Python virtual environments. And while she's sharing her screen, I just wanted to mention that the webinar is being recorded and it will be available also after the webinar through the MIA YouTube channel. Okay, go ahead, Mariam.
Yes, I just want to ask, the main session will be recorded. We have a breakout room session later on where you can really ask detailed questions, and there we will see that your questions will not be on YouTube, of course, so don't feel shy because then it might end up on YouTube. Okay, so about virtual environment. Why would you want a light-weighted yet isolated Python environment? And with this, I actually mean a virtual environment. And I would say, especially today, you would actually want that because, for example, you might be working on your PhD project or something, you need certain versions of your packages in Python, and now today we are installing certain things, and this might mess up actually your fragilely set up system. Suddenly have different packages and suddenly nothing works anymore. And in order to avoid that, you can actually use a virtual environment. And I will very briefly show you how you can do that. So here are the commands, but I think I would really like to invite you to follow me doing that. I have it on, oh, sorry, I have an error on the Linux side here. So I will tell it later. But I would like to show you really how to follow that, because then you can create your own virtual environment immediately. And I think that's always more helpful than if I just show you the commands. So if you work on Windows, an additional folder inside. So I'm here in the tpyproof folder. A place where I cloned the Python package into. And to easily access it actually at this location, I can basically just type CMD here, and then I have my command prompt opened. So on Linux or Mac, you would open your terminal in parallel. So what you would do if you want to generate a virtual environment, and a virtual environment is actually really just what I asked at the beginning. So it's a really lightweighted version, basically, of your Python environment, where you really locally in this folder then have stored which packages and version of these packages you're using. And for example, if I would now install ppipu, it would actually only install it into this virtual environment if I do it from Git, but this you will see later on. So how do I create this virtual environment? So I call the Python command and then m. And venv is actually a command within Python. So it creates a virtual environment, and I would actually call it also virtual environment. So I would call it twice venv, but here you can also call it virtual environment. So I can do it this way, but yeah, usually I use venv. It's short and it's very clear that I always have the same name for a virtual environment. And if you look at my folders, so it will take a little bit of time, but that allows you actually to type the same. On Linux and Mac, this is exactly the same command, as it is not system dependent, but this is actually within Python. So for this, you can use the same command. And we are quickly waiting. So you see here, it actually created me this folder, virtual environment. And if you go on the folder, you see like here is the scripts, and then it will copy also the activate bat, and that's actually the one we need. On Linux, it's slightly different. It's the virtual environment, and then bin, and then activate. So you will need a slightly different path. So you will need the bin in the path. But I'm on Windows, so the next thing is I would go to my, created it before, so I can call it venv, or otherwise you call it virtual environment, as whatever you call the folder now. Then you can go to scripts. I always use the tab because then I see like whether I'm in the correct folder that actually exists, and then activate. And then we are already there. So yeah, this is now everything that has this venv before, or the virtual environment, however you called it. That's why it's nice to be short, because otherwise you have a very long line. You see like that you're within the virtual environment. So yeah, whatever you would do in here would not affect changes on Python packages, would not affect your main research, for example. Or for example, if a colleague of you shares his or her project with you, you can really just open exactly the same virtual environment. You can install directly the requirements from .text, and then you have everything set up here locally. Okay, in the breakout sessions. So I would like to hand back.
Okay, thank you, Marianne. And the last presentation before we go to the hands-on session is by Florian Bank. He's a PhD student at the EWAC, and you can maybe share your screen and start the part related to ppipu Python package.
So thanks for handing over to me. Can you see my screen, or?
Yes, we can.
Is everything working?
Yes, yes.
Okay, perfect. Thanks. So What I will do now is I will quickly introduce you to the Python package PyPy-poo, which is an open source Python package for modeling of water resource recovery facilities. And then a bit more in depth go into how it was built using Git and what benefits basically the user had if it's built using Git and then also deployed on a shared code base which supports Git. So good. So basically to give a quick overview, the PyPy-poo is designed to work like this. So for example, you have a certain system that you want to model, and you can, for example, in this example, have a really simple wastewater treatment plant, but it can, of course, also be more complex. Then you can represent this using PyPy-poo, which is then shown with this code. And finally, if you have written this, you can simulate it, and then you get the outputs of the system, how you simulate it. This is actually here a steady-state simulation, but of course you can also do use dynamic influence, and also later you will have the possibility, along with the breakout sessions, to have also a deeper introduction into PyPy-poo. However, first I'll quickly say something about the functionality it has. So it was we designed PyPy-poo to be flexible and modular. So basically that different types of reactors and settlers are on one hand available, but they also can be added easily. And then these different subsystems can be connected and simulated together. Further, in each reactor, the stoichiometry can be directly entered and edited by adding a table. Then, secondly, we thought of performance. So we want to have the simulations run fast in the end. So the system of equations that results from the system is then simplified, and only the necessary parts that really represent the core system are then solved in Julia, which yields a much better performance than solving in Python would. Then the framework is fully transparent, meaning that all equations can be retrieved at every stage. And finally, it's directly written in Python and Julia, so it can be integrated with any other Python or Julia package. So for example, if you would want to include some data-driven parts in the model, you can do it quite easily. So now I'll go a bit back to Git. And basically, if you have the project webpage on Git, you see it here. You can find it here on GitLab. For example, GitLab is an alternative to GitHub, which provides a similar service and also has some code sharing possibility. You can find this website here on gitlab.com/.info/pypy-poo. So if you go to this website, what do you see here? So on one hand, you first have the title of the package. Then you have all code files that are associated with it. And then the README is shown. The README usually provides, depending on the package, a shorter or longer introduction to the package. And then also often it contains a link to the documentation. So for example, here using Git, we can directly host documentation for this package, which you can retrieve by clicking on this link. So if you do this, you get to the documentation, and here the package is described more in depth. And then further, you can also see here the installation, and then also some examples how you can use the package then. Often for other package, it's similar. Mostly you also have some examples and installation instruction. Further, often you have really the documentation of all function, which is here called API reference. We can go and look at every single function you might find in the package. Good. Then to go back to GitLab, what it else provides for the user. So you can see here, besides the files, here above, you have a small sign which says here main. This directly indicates the branch which Christian talked about before. So if we go on here, we see different branches that exist. And here we have a main branch, which is the default branch, which you usually use to install the package from. And then on the other hand, there is the dev branch, which is here containing the development version. So, and this is done here and often done the separation between a development version and a released or main version is that, for example, if a developer works and just changes a small thing, which might or might not work, it isn't directly on the main version of the program. So the advantage there is that if you as a user are working with the version on the main branch, it doesn't get directly destroyed once a faulty change is committed. Then further, you can see in the top right corner here, there is this small green tick. And this small green tick here, you see that it's written past. If you hover over it, this is an indication because most Git web pages allow you to create so-called actions or tests or similar things. So here we implemented some tests which automatically test the code functionality and if everything works as intended. So basically, if there is a green tick here, it's good and means the tests passed and the functionality should be there. Otherwise, there would be a red cross here. Good. And then finally, if you go here on plan and then on issues, you get a list of several issues that are considered with the package. This can be considered kind of a to-do list for the developers, but to this to-do list, everyone can contribute. So, and usually it contains either bugs, which people or the developers themselves discover. So everyone can make issues and then describe the bug here, and then the developers get notified of it and can check if it's really a problem or help or also add some functionality for the package. For example, if you can also submit a feature request as it was done here. Good. So how would you proceed to add such an issue? Everyone can do it by just going here and then clicking here on new issue. Then a new window would pop up. Probably you would need to sign into GitLab or the respective web page, and then you can simply add your issue here, which is then just the question which you have or the problem, what doesn't run, or also the feature or enhancement request that you might have. And yeah, with this, I will hand over back to Saba and then to Shu.
Thank you, Florian. Okay, so let's quickly start the hands-on session part, so you can see how these tools can be used in practice. First, we have a brief hands-on session by Zhu. He's a PhD student at Hong Kong University of Instrument Science and Technology. And so we will start with him, and then after that, I will explain you about the breakout sessions, and we will go through that so you have also opportunities to ask questions on different topics. Okay, Zhu, the floor is yours. You can see your screen.
Okay, can you hear me clearly and see my screen?
Yes.
Oh, great, thanks. Hi everyone, I'm Xu from HKUST. So now we are going to the hands-on session. Like it's basically a wrap-up of what Christian and Mariana and Florian have said already. So it's a practice. So I here invite all of you to join me to practice about this Git and PyPop. So first, before we start, I believe like everyone received the message that we need to download the Git and Python and install often. And also, like I suggest that you can all install the latest version because there might be some problems happened for the previous version. And then afterwards, we need to build a repository. Like there are two methods for build a repository. The first one is built from the ground. The second one is just a clone one, which I type here in the chat box so all of you can. Mariana, can you share it in the chat box? Thanks. So for this scripts is created by Mariana and Saba. So it's a starting point for you to go into the Kaggle competition. And by the way, you are all welcome to join this competition. So to clone this repository to our local repository, it's first we need to create. Sorry, it's Chinese, but just create a folder. You can call it competition. Yeah, and then afterwards you just click in and you type cmd here. And then you will see here, competition. And then you click git clone and you copy this web address and press enter. And then you will see the Kaggle competition is cloned here. And then if you want to go into the Python, Kaggle competition and Python, you just cd Kaggle competition and Python. So now you see we are right there. So the next step is to create and activate a virtual environment, which Mariana already said. So we do it again. So it's just a Python and virtual environment and whatever name you want. So we follow Mariana's suggestion. We use v and v and press enter. You see it's creating. So let's wait for a moment.
And yeah, if you need to do it for Linux or Mac, I had copied earlier the command then for the activation part, just while we are waiting.
Thank you, Marina. So now you see I think we already created the virtual environment. So now we want to activate it. So it's a virtual environment. This is your virtual environment names, and scripts activate. Let's see. Oh, sorry. Script activate. Now you see there's a square. So we are now in the virtual environment. So the next step is to, because if you see the those for the Kaggle competition scripts, we have all the requirements in the txt file. So for example, the NumPy version should be larger than this one, and matplotlib and pandas, and the most important one, which is the ppypo installations. So here we can easily install all of them by just pip install r requirements .txt. So you see now it's collecting ppypo requirements txt and cloning of the ppypo from this GitLab, and then it's installing. It will take some time, but won't be long. So while it's cloning, like because for me it's already installed somewhere, so it's it's quick. But for you, it might take some time. Okay, it might take some time. Okay, so before that, so if we want to get it run, we really need to change a little bit code in this script, because it's about the input input data. So we can edit wherever you want. So I'm just editing it in a notebook. So we can search influent. So here in this row, we change this to, we add just 3 things here. And if we want to plot off the, we want to plot the graph, we can delete this one and we save it. Oh, it's still downloading. So to save time, I just open another one, like another competition, Kaggle competition and Python. Like it's assumed like we have already downloaded everything and pipped everything. So now if we want to run this script, we can just type Python as competition.py. And you will see it's running. Sorry, just maybe wait a moment. So I think afterwards we will see this nice graph just pop out. And here, if you are using other IDE, you can just run it with, for example, PyCharm or Spider or VS Code as you want. So here for the convenience, just using the run the Python here. Okay, it will show up soon. Okay, maybe I didn't change. Maybe I didn't change the Now it's show up. Okay, you can see this nice graph, which means you successfully run everything. And afterwards, we can try to add and commit your scripts to the local repository. So let's do that. So here, first we can check our Git status. You see, the S competition is change is not staged for commit. So we can and for the stage, I think there's nothing here. So first we can add it to the stage by using git add as competition.py to the stage. And now we check our status again. Git status. You see, so there's one file which can be changed to be committed. So we can do the commit now by type git commit and whatever name you want. So here I just call it commit1. So you can check the files by using git log to check which one has been committed. And afterwards, if we want to, for example, by the way, if we want to exist from this, you just type Q, and then you are existed. And then afterwards, if you want to revise and compare your previous version, or compare your staged version versus your local repository, and you can just, for example, here, in my original, in my working directory, I just change it. Maybe I change the, here, I change, for example, before we don't have X label and Y label. So now I add X label and Y label to the script. So I save it. So which means I changed this file. And then here we can type git diff, and you'll see it automatically locate where you have revised your code. And then you can add your revised code to the staging area by just repeat what we have done. Git add as competition file. And I think it's already added. And then you can type git diff again. You see there's nothing showed up, which means your working directory and your staging area is the same. And now, because the changed file is in the staging area, you can commit it to the local repository by using git commit and commit to. Okay, so now if you want to see the difference between your staging area and local, I think I already uploaded to the local repository, so there should be no difference between the staging area and the local repository. So let's see git diff staged. So you see there's nothing showed up. And so here is everything about this hands-on session. I hope we learned something from here, and we can have a good starting point to do the competition. So I will hand back to Saba.
Thank you. Okay, I think this was a nice overview of how we can use a little bit in a simple way, how we can use the tools that we have presented to you to have like a working pipeline from the beginning to the end and work with the materials that are available for the competition. With that, I would like to now go through the breakout rooms. So now we'll have breakout rooms, different breakout rooms on different topics that you have also been presented. So we have 2 rooms on Git, so the topic, 2 rooms on the competition generally that you can, and also 2 rooms on the PPyPoo, I think. So you can, let me just check the rooms. So if you just open the breakout rooms, the bottom on the bottom part of your screen, you will see the rooms and also the title of the rooms. So we 2 rooms, as I said, on the Git, 2 on the competition, 2 on PPyPoo, and another one that it says participants help participants. So you can also help other people that are present in the webinar. So feel free to join any of the rooms if you have questions on any of those topics, and ask the people who are available in the rooms to answer your questions. You can also switch from one room to another whenever you want. If you have then 2 questions, just go to one room, ask the question, and go to the other one if you want. Also, if you see that one of the rooms is free, you can also come up with your own topic, not necessarily any of these specific topics that we put as the title of the rooms, and then go to the room and ask your question, and people who are there are most probably able to handle your questions. So with that, I would like to invite all of you to...
In the main room, Christian will keep presenting something on advanced Git. So if you're more interested in stating your own questions on a presentation, then stay here.
Or you don't have any specific questions related to that, you can stay here in the main room, and Christian will present still something on a bit more advanced stuff with the Git. So yeah, feel free to stay here or join any of the rooms for your questions.
So I will wait until everyone is reassigned. Okay. Well, I would like to continue with more commands that you can use that will be really helpful in your workflow. And one of them is how, after you submit a commit, can see the commit list. And that command is a log. I will suggest one line that you add there as well, because otherwise you will have a really, really long list for that. And that will show something like this, something that has 2 really important things, 3 actually. The first one is the unique ID, and that you will need it afterwards for operations with that specific commit. The second one is where are you right now? For example, you can see here in the first line that it says main. When you commit to a certain branch, you will at the beginning will say where actually you are committing. So here is in the main or the master branch, as I said at the beginning. And the third one is a description, that here is where we really emphasize that you will be really, really meaningful and detailed in what you are improving to. When you see this list, know where actually you are looking for the information. Afterwards, if, for example, you made a mistake and you want to come back from a to a specific commit, there is where you are going to use that a unique IDEA identifier. You go and, for example, here you can see I want to go back to the beginning from the specific project that you are working on. So you type git reset and the unique identifier that will really help you to restart over and don't lose in what you are doing. And as well, other useful command that Xu already showed to you is clone. If, for example, you see in a Git or GitHub that is more commonly saw a repository that you want to download to your local machine, you can use this command on the terminal, so git clone, and you can copy the source there, and you can insert it, and that will download everything that you have. It's important to say that you will download the master branch. So if you want to clone another, I'm sorry, that this will download everything. So if you want a specific branch, you need to specify it there. For more information, you can use the help command that is really helpful for everything. And then, well, I think that what is important to say is what is actually a branch, because yeah, I said along this presentation a lot of the word branch, but what is actually a branch? And Git described it as a pointer to a snapshot of your change in the files. So basically, we can summarize it as a copy of the current work that you have been doing in a certain time. That means that if you, for example, create a copy of your file and start working on that copy, that is your new branch. That is it's what you are modifying aside from the normal folder that you have, the main folder, that you can merge it again afterwards. So how can we create a branch? How is that process? It's really, really simple. You basically type git branch and the name that you want, and that will provide you two things. I'm sorry, that will create the branch. That will say a new branch create. And then when you type git branch, that will show you two things. The first one is the current branches that you have created. That means if you have created the master branch and a new branch that is called model version 1, that you will see the two, and you will see a mark next to the current branch that you are working on. And that's really, really important, because that means where you are actually making the changes. Could be master branch or could be other, and that's important. You have to take into account to know mistakenly working on a branch that you are not supposed to. As well, if you want to switch between branches after you see the current branch that you're working on, and you want to switch to another or create a new one, you can use this command git switch, and you can switch it between branches, which will basically allow you to work in others. And then you will start normally working on those. You will start developing all your work in each of them, and then come something that it's really, really, you need to be really, really careful on, and is the merging. Because if you work alone in your own project, in your local machine, probably you will work in a certain branch and you will develop all your work there. But if you want to merge them again, probably you will encounter some issues. That depends on what you're trying to merge. If it's a text file, it's completely different. If it's a Python file, a C++ file, or other, or JavaScript, or whatever, because you could change different kind of structures. But let's say that the normal command will be git merge, and you, as well as we mentioned previously, you can add a message. This command here, the M, will always refer to a message. So you don't get scared. If you want to add a message into a certain kind of line, you can add it this way. You can type the M and then the message that you want to add. For example, here, new unit process, and then you will merge them together. Ideally, the working flow that you are going to go for is you start a project with a current model, and you create a branch to solve a certain issue or to add something, and after you solve it, you merge both the master branch and the new branch together to integrate the new developments of features that you add, and then you delete the branch that you have previously working on. Why do you do so? Because you already have everything that you need in the main branch, and there is no other reason to have the older branch aside. However, you can keep it there if you need something, even if you delete with the command that I'm going to show, I'm about to show. You can restore it afterwards, because it's really hard to delete something in Git, because it's basically built to keep track of everything that you have in them. But if you want to just keep a single branch for your project, and you will create others, I mean master branch for your project, and you will just create others for solving issues, you can use the delete branch command to avoid to delete the branch that you are not working any longer. The command is very simple, is git branch delete, and you use the name of branch, and that's it. Yeah, basically I think that covers most of the commands that mainly you will use. Other I don't know if maybe you have any questions regarding maybe the commands that we saw, or you have any comments, please just let me know. I will gladly share with you any information. If not, I'd like to come back to this slide. There are no questions? No, I don't think so. When to talk a little bit more about the merging, when you are merging two different files, for example, you have the original file here, and you have a branch that you implement these two new approaches, the system will ask you, will encounter an issue, will encounter an error, and will throw you probably definitely an error, and will say what exactly you want to keep. You want to keep this structure or this structure that you have here, and it's normally if you're working alone, probably the issue will be delete one of the two and integrate it in the final model. For example, I delete here this component and I include this one from here, and that will be create my final model. But normally, if you are working with other people or if you have other problems, probably you will encounter errors that you will need to refer to the documentation, because you will need to track where those errors came from. For example, normally, if I cannot merge from this model, this one, I will need to merge it from this part and then integrate the remaining from the next one. So keep in mind that the important part of actually commenting the commitments at the proper documentation will really help you in the merging part. Probably not in the others, but when you try to merge a branch, that will be really helpful, because you know where exactly you need to look at for information to merge your final part and have your new model. Yes, the idea is to have a record of all the information that you have been working on, and that you can implement this in your projects to not suffer anymore about losing files or not be able to return to a previous version, or simply if you want to retest a new model, the first model that you try, you can do it really easy with this kind of system as Git.
So your silence is that you're done, because I would then call everybody back from the breakout rooms to the main session. Did I interpret that correctly?
Yes, yes. I was actually waiting for you. I thought that we were in a breakout room. Yes.
Okay, okay, good. It will take 60 seconds until everybody is back in the main session.
Okay, are we all back in the main room? I think so.
Yes.
That's okay. Yes.
Okay. So I hope you at least got answer to your questions in different breakout rooms on the different topics, or you may have followed the Christian presenting a bit more advanced stuff on Git in the main room. I would like to just have an idea about a bit of feedback about what we have presented, and I wanted to ask you to show by raising your hands with the reaction button at the bottom, who could actually follow the hands-on session on his or her own computer, the part that, for example, Zhu presented about initializing a Git repository and doing everything until the end. So we can maybe get an idea how this went.
So what kind of reaction do you want, Saba?
Raising the hand.
Raising the hand.
So for those who did not, actually, what is the issues? Where did you get stuck or so?
I think we should also ask the opposite question. Not everyone probably did it.
Very true. So who actually tried and didn't manage to follow everything?
No shame.
It's either this or the previous one, so I think.
Yeah, some people wrote that they couldn't actually on their computer follow, you know. So it's actually really important that we put it online afterwards, that people who still want to do it on their own computer can do it actually. Nilay, did you get help like in one of the sessions to figure out like what could be the issue? Okay, so I would invite you that you come to my breakout room afterwards in order that we can try to address your issue actually. And then I will hand over to Saba.
Okay, thanks. Yeah, I saw two comments that it was a bit too fast. That's true also. There's a lot of stuff covering in a limited time, but it's good that the presentations parts are recorded so you can follow or watch the video again and then follow that at your own pace. So maybe let's move to the last part. So Florian will show us a bit of another part of the hands-on session, which will be mainly an example of the PPIPO and a bit of a workflow there. Yeah, so I will hand over to him.
Good. So thanks for handing over to me. I will introduce now to a small example using PPIPO. But for this, if you want to follow it, I just now send. Okay, I'm actually not allowed to send the mail by Zoom. But I think you can get it then afterwards, the example I'm doing now with the slides then. So the example I'm planning to do my screen for this is with a so-called Jupyter notebook, and sorry, it's a bit too loud. In the zip folder you will get with all the files, there will be also a short explanation on how to install all of this and how you can get this running. So the example is actually showing how you can build this very simple ASM system, which you already saw on the beginning of my slides. However, here the implementation will be followed a bit in more detail. So to model such a system, of course, in the beginning, we need to import all dependencies. This is, of course, PPIPO, but then also NumPy and Matplotlib, which we use for handling arrays and then for plotting. Further, there are some dependencies which are then only used for just the Jupyter notebook and displaying everything nicely. So if we continue, we can see that we have this block diagram of the system that we want to model. On one hand, this we can also represent then in this a bit more code-based manner, where we have first the influent, which then connects to a unifier, which is basically here, which unifies the influent with the return sludge. Then the output of this is flowing to the reactor, then to the clarifier, where on one hand you have the effluent, and on the other hand it goes to the wastage pump, from where you have this wastage sludge, and the other part goes back to the unifier and gets recycled. So to model this, we at first need to have the reactor, which is the core part of this system. The reactor basically works with the so-called stoichiometric matrix, which I also prepared, and we will receive it with the code in the end. So this stoichiometric matrix, I quickly read in here and displayed here. You can see it here, and there you first define all state variables the model will have, and then in each row defines a different process, and here in between you have the normal stoichiometric matrix. In this example, it is simply the one of the ASM1. And then in the last column, the according process rates are defined. Basically exactly as it is written in the stoichiometric matrix for the ASM1 and in the ASM1 paper. Similarly, you could define this for any other process, including ASM2, ASM3, or whatever process you might like. Then further, we also need to specify the parameters. Here they are specified in the same parameters, and I quickly show them here. Maybe let me quickly execute this first. And the parameters here conclude all different parameters you have in the models, and here as well the parameters of the values of these parameters. You could also omit these values, then it's just assumed that it's provided at runtime, but currently we use it as such. Then the reactor can be defined, which is here a simple CSTR. So here you have the first specified the volume of it, then the initial state. Here we have exactly the same order of initial states as defined here in the stoichiometric matrix. So it needs to be adhered to the same order. And then, of course, the file where the stoichiometry is defined needs to be specified as well. Further, then a name can also be given to the reactor system. So we can execute this, and then we get a good new reactor. Then we also need to construct all other systems we need, which for the system, for example, the clarifier, the unifier, and the wastage pump. And then also we need to specify the rate, the pump rate, which is then the sludge wasted. Here we can provide it as a percentage, so specify it as being 25%, and also how much sludge is taken out at the underflow of the clarifier. And execute this as well and construct this. Then we import the data for the influent. Here we take the influent, the rainy weather influent from the BSM model, just as an example, but similarly, any other input could be used. Then using this, we make a piecewise linear interpolation between these values to have a value defined at each time instance. And yeah, so we can execute this as well. And now we have all systems we need ready. Then we have basically, as it's shown here, we have all 5 systems created, but now we still need to connect them. How do we do that? We say from a system, we can add, for example, an output connection. So we connect the influent to the unifier, and with the output connection, so we say the influent has an output connection to the unifier, and then which port we need to connect. But if I'm looking now on time, I see that we are running out of time. So I think I can stop here, and as you will get the file afterwards, you can then go through it as on your own, and then you will have everything here. You have everything explained very nicely in this Jupyter notebook. And then in the end, you can simulate it, and then you get a nice plot of the effluent of the plant. And in the end, you can also look at the equations that are generated for the reactor, and then also for the overall system, including the settler and the repeat back sludge as well. So yeah, with this, I think you are equipped to then go through this example on your own once you get the files, and I will hand back to Saba.
Thank you, Florian. Okay, we are almost at the end of the webinar. Thank you all for joining the webinar. I would like to thank you for being here on behalf of all the other Hybrid Modeling Group Management Committee members, and also Mia. As we have said, so the video recording of the webinar, the main presentations and also the main session will be available on the MIA YouTube channel. So be sure to check that. I think Marcelo has put the link to the YouTube channel of MIA in the chat. And also the competition site on the Kaggle is also quite active, so we will monitor there. So if you have issues or questions regarding the competition specifically, you can also raise the question there, and we will check and answer your questions there. And you will also get information about us at the Hybrid Modeling Working Group, who we are and how to contact us through the MIA channels. And then you can also contact us directly if you have more questions or more doubts about any part of the webinar that you have heard or the competition. So I would like to wish you also good luck in the competition. We hope that many of you would compete in this competition, and in 1 month we will have some winners, which will be also announced during the next WRRF mod in the US. I don't know if Marianne or anybody else would like to have something. If not, I would like to close it here. Thanks to everyone who joined the webinar, organizers, participants, and see you soon in the next webinar of the MIA.